Welcome to another Algebra 2 video. In this we're going to be looking at the tangent functions, and we're going to basically be looking at the parent graph and how the key features, domain, range, increasing, decreasing, or I guess just increasing in this case, and the positives and negatives, and we're also going to look at the period. So the graph that we're going to look at again is the parent function, so y equals tangent of x. And if we remember right, tangent of x is actually sine of x over cosine of x. All right, and going back to the unit circle, so let's get this circle so we could kind of remind ourselves of this periodic function. There are places in the unit circle, primarily pi over 2 and 3 pi over 2, where my sine value is 1 and my cosine value is 0. In this case, it's going to be 0, -1. And if I'm doing this correctly, if I'm looking at 10 correctly, so let's say 10 pi over 2. This is going to equal 1 over 0. And this 0 is problematic because anything over 0, you're dividing one item into nothing. And when you divide one item into nothingness, this doesn't equal 0. You're not actually putting it in anything. This is actually undefined. Put a little period there. And when this is undefined, what we would really have, what we're looking at graphically, is a vertical asymptote. So looking at this happens every time that I hit these. So if I go 2 pi around and then continue going, we would continuously hit these undefined graphically. So this does allow our shape, this allows a certain characteristics of a tangent function graph. So the sines and cosines, you remember, were waves. Well, this is what the tangent one looks like. It has these kind of places where you have vertical asymptotes, and then the graph itself increases. Vertical asymptote, increasing graph, vertical asymptote, increasing graph. So we have places where we are undefined. So this comes into play for my domain. Let's start first, though, with identifying how big or how far apart each of these vertical asymptotes is. Well, if I'm looking at my unit circle, it's really just half a circle. And half a circle is pi. So I can now say my period, let me grab a different color, that's a little bit easier to read. My period between the undefined, from here to here, the length of this is pi. That means every pi units will have this vertical asymptote if we start at 3 pi over 2 and so on and so forth. All right, so now this plays into my domain. So looking at my domain, x cannot be certain numbers. And if I'm looking at this, x cannot be even values. So what I'm going to look at here, and each of the, even values, odd values. So, and what I mean by odd values is this is pi over 2, so that's 1 pi over 2. Then the next one, the numerator is 3 pi over 2. The next one would be 5 pi over 2, following by 7 pi over 2, and each one of those would be a vertical asymptote. So we have an odd number in our numerator and then 2 in our denominator. So what I'm going to write this as is pi over 2, because again, this is where we see our first vertical asymptote. Then I'm going to add pi to that to get my next vertical asymptote. Remember, to get to the next vertical asymptote, I'm going to add pi again, and pi again, and pi again. I'm going to do this x amount of times. So what I'm going to do is I'm going to say n times pi. Every pi over 2 plus n pi will give me that vertical asymptote, or values that x cannot equal. And I forgot to put the x cannot equal before I start all this, so let me rewrite that. X cannot equal. I just want to jump straight into defining this. And n needs to be an integer, so I'm going to call that out, where n is an integer. And curly brackets, not parentheses. And so that means that x every pi over 2 plus pi, plus 2 pi, plus 3 pi, plus 4 pi will have this vertical asymptote, and you cannot include that in your domain. Now looking at the range here, it really, really does not matter because we go from negative infinity to infinity. So my range is all real numbers. Okay, the next thing about graphs is we need to look to see, do we have any places where we increase, decreasing? How is our graph doing? Do we have peaks, valleys, valleys, maximum, minimums, things like that? And looking at my graph, we're always increasing. My slope is always positive. My average rate of change is always positive. So the graph, grab a different color, the graph of a tangent x is always increasing. Remember, we look at the average rate of change for this. There is no average rate of change, there's no slope, there's no maximum or minimums, it's just always going up. The average rate of change is always positive. There is no place here where our slope or average rate of change would be negative. Okay, so the function is now, we have to see positivity and negativity, which means we're looking at the y values, when the y's are positive and when the y's are negative. So look at this, we have pi to a pi over 2 here, so negative pi to pi over 2. We have 0 to a pi over 2, so it looks like we're going in, this distance here is pi over 2. So it looks like we are positive, the function I like how I kept the orange. Let me flip these around here. Keep our colors straight. The function is positive for every interval. And it looks like I could say n pi. So if n is negative 1, we still have pi, so negative 1 pi. 2, there's that pi over 2, so I have to think about how I want to do this. I'm going to do it right just like we did above. So pi over 2 plus n pi, where n is an integer. N is an integer. All right, so let's look at when it's negative. So the function is negative for every interval. I have a little bit of space down here. All right, so we look between the 3 pi over 2 to pi, negative pi over 2 to 0, pi over 2 to pi. It looks like we start with something over 2 and end with a pi. So I am going to do, and it looks like we subtract it from this. So it's going to be negative, actually I'm going to do n pi minus pi over 2, comma, and then n pi. So it's kind of like this part right here, except we're subtracting because we're going from here, but we're subtracting that distance here, subtract that distance. All right, so there we have it. So we have all the key features of a tangent function. The biggest ones to note are my domain, because that's a little bit different, and these guys right here are a little bit different because we have that repetitive action. We have those periods. Since this is a periodic function, we have that kind of repetitive. So we do introduce this integer n to kind of help us facilitate that repetitive action. All right, guys, so this is the end of the video. If you guys have any questions or comments, always feel free to ask, and I'll catch you in the next video.